the good part about AI and the bad part about AI is it's almost like a little bit of magic, that you give this old data to this AI algorithms, and it can actually find the behaviors and the math itself. You don't give it any, like, I'm not telling it it's the wind speed divided by the angle of the table or whatever. I just provide the data.
Johan, CTO of Misproven. Welcome to Shit You Wish Your Building Did, our podcast, of course. I just really wanted to have a conversation with you. Been watching your company for a while now. I think you're doing some really interesting things, and it really fits in with kind of our ethos here about having discussions, of course, about technology within the built environment and how, you know, we're using it. And specifically today, right, to talk about artificial intelligence. That's something that we've been looking at in our research, and of course, like you guys being experts in it.
So we have a quite ambitious goal. We basically want to save the world.
Nice.
And our vision is like reduce the real estate sector should reduce their carbon footprint by 1%. It sounds like a small goal or a vision, but it's quite big. So everything we do is having that in mind, basically. I could tell you a little bit why we have chosen Misproven as the name. So it's a bird, bar-tail godwit it is called in English, and there's been like research on this bird, and it does a non-stop fly between New Zealand and Alaska, so without sleeping or anything. And the reason, and it's the bird that can fly the longest. The reason is that it's very good with the energy reserves or the fat in the bird, and it also makes like this good decisions, which seems kind of like weird, but it flies against the wind for a long time to get up to the jet streams to make a faster flight and so on. So we think it's both a little bit smart and also good with
and energy efficient.
Energy efficiency.
Great name.
Yeah, thanks.
And where are you with the company? What stage are you at the moment? How long have you been going for?
Yeah, so we've been for 4 years. We're still quite small. We're 25 people. I think it's good.
Yeah, absolutely.
And we're
much
like
bigger than my company.
I think I've been to like 7 interviews, trying to recruit more people and so on. So I would say we're in like scale up phase.
Yeah.
Like starting this building in other countries and a lot here in Sweden, of course.
And specifically, you know, what I wanted to discuss with you is artificial intelligence. Yeah. I mean, that is something that is certainly within the kind of like your marketing of your product and service. And, you know, we've had discussions off camera about that and its implications for real estate. And it just really came together because it's something that has been a focus of some of our research work over this year. So, I think just to dig into that a little bit, I mean, what are your thoughts? Well, first of all, let's start with sort of your company, Misproven's technology. Like, how have you used AI in your product, and how are you using it to, you know, make property 1% more efficient?
Yeah. So our goal is to save energy for the buildings, and there in every building, we would mainly work with like complex buildings, like shopping malls or normal office spaces or hotels and schools and so on. So in all of these buildings, there are lots of sensors. There are like thousands of sensors. There's usually like a BMS system in the building, and all these sensors are connected to the BMS system. And traditionally, there has been like these manually entered rules. Like if the outside temperature is below this threshold, then the fan should spin in this way or so on. But the problem is that there has to be like a lot of engineers who understands the building and who does this optimization and try to make everything go in the optimized way and so on. But the reality is that there are a lot of like change of weather, like wind speed and sun radiation and all kinds of, and the amount of people who are in the building and so on. And it's usually the optimization that has been done manually, it's quite simple, if you say in one way. I don't know if that's the right word, but they've put in this normal, like if this, then that rules. So instead, they're in the data from all these sensors, they're actually hidden within that data that you can realize how the optimal way to run this building would be. So you have to, we use, AI is quite a broad topic. We're especially using machine learning, part of it. And I don't want to bore you too much with all the inner details, but
that's the whole point of this podcast. You can bore me.
We have the like supervised and unsupervised and reinforcement learning, and so on. And we're using a combination of these, and especially when it comes to like reinforcement learning, then one of the big problems is that you need a lot of data.
Yeah.
We have a lot of data, but in this case, in the traditional data science way, we have too little data, actually. So we have to combine like domain knowledge from the building together with machine learning to make a good optimization of the building.
Okay, and what would you say is domain knowledge? Give me an example of what that might be.
So this comes down to a lot of like thermal effects of the building and so on. And this is the reason why we have like a lot of engineers and so on in the companies, and like people who have PhD in applied mathematics and so on, quite good people who sits with this things and make it.
So sort of in my simple understanding, you're taking then the real data, right, from the different sensors, from the building management system, and then you're creating this data using mathematical models. So let's say, for example, the way that heat is flowing through that space.
Yep.
You have an idea of that, and you bring those two things together.
Yeah, exactly. And like we can guide it also a little bit. Like this is a normal thing with like correlation vs causality. We know that if the heating is going up inside, it's not the room who are affecting the outside temperature, but we know that it's the outside temperature who affects that thing. So we know what direction the data is going and so on. So we have to guide the AI a little bit. If we were just giving it data and it was to learn from a building, it would probably take like 10 years of just collecting the data.
Because you can't get enough.
No, because we can't get enough. I mean, it's still big data that we're doing, and we have like millions of sensors and all of these. But for every building, we actually build like AI models for that particular building. So every building has their own models, and in that, it's too little data.
Yeah.
And we wanted to actually start optimizing the building in like 1 month time. So we're collecting data for 1 month, and then we can start optimizing it. And then it gets better and better and better. So it's a way of like self-learning capabilities, the more data that are collected and so on.
Okay, yeah, no, that's fascinating. Because in my head, then I'm also thinking, as you said, no one building is particularly the same, depending on where, like how much glass there is and where the sun's coming in and stuff. So, and in where it doesn't matter so much anyway, right? Because you can take that into effect, or
exactly.
at least the software sees that as it develops.
And it's not only like there are different building materials, but there are different like pumps and different, so many. I mean, basically every building is unique. There is not like the one building is looking like the other building. They're really different. So
So within those sort of two separate parts of the business, I mean, where have you had some of the biggest challenges? Because I almost see, like, if you look at the BMS side of it, right? I mean, again, that's like a challenge, because you've got to try and get the data out of that BMS, and there are lots of different vendors, and it might be old or etc. And then also this kind of really mathematical part of it as well. Like, maybe you could talk a bit about that.
think we did a quite challenging thing when we started this. So we have like 10 or 15 integrations to different systems, BMS systems and so on. And some of them are very modern and some are not and so on. And we both had to we have to do 3 parts. We have to be able to read out the data. We have to be able to write set point values, pressures, fan speeds, and so forth. And the third part is that we need a fallback solution, which means that if we lose the internet connection or something goes wrong or whatever, then everything reverts back to default that it was before we came into it. So all this logic can't sit outside the building. This fallback needs to be inside the building, since if the internet connection goes down, it needs to otherwise equipment could actually freeze and so on, could break. So it's a lot of just all the integrations is a major part. We have a team working with just the BMS integrations, and then the AI part is another another quite challenging part. So yeah.
How do you feel in general about the way that AI is sort of marketed? I mean, again, it's not just Proptech commercial real estate, is it? In general, I feel like there seems to be a disconnect, and we wrote about that in the report, that it's being used as a marketing term now quite extensively, and the understanding of what it is and what it isn't, there seems to be a disconnect there. What are your experiences with that?
Yeah, so it's quite fun actually when we do interviews and so on, taking in people, and we take in data scientists or whatever, and their first question is okay, so what frameworks are you using or so on. They want to see if we're actually an AI company or not, and if you're not doing TensorFlow or PyTorch or something, then you're not doing AI and so on. So and they're oh, so you're for real. But I totally agree. There are so many players out there, not for only the real estate, but in a lot of other fields, which say they are using AI, but they basically have some. It seems like they've done a little bit of math and put in some algorithms and so on, but it's not what we mean with AI or machine learning.
So where is the line for you then? Because you mentioned there, for some of these platforms, TensorFlow. I think that's the Google one, isn't it? Or yeah. Is that where, or where do you draw on the line between, let's say, a company that is doing AI and is not?
Yeah. So now I will try not to complicate this, but for me, it's if you're using the gradient descent or backpropagation thing, which means that basically from just the data that you have, that you're understanding the relationships and so forth just from the data, that you don't put in any other just a math way of solving it. And all of this is smart people back in the 70s who did this. And I would say it's quite well structured when you're doing, at least in my mind, when you're using AI and not if you're using this backpropagation thing or not.
So backpropagation, would that be an example? Some of these statistical mathematical models, like Bayesian inference, that is, whilst that is an algorithm, it's not really AI, right? Because it's not learning, it's just making a decision based on statistics. Yeah. Is that sort of an example?
Yeah. Okay. I mean, you could take anything. If I had some kind of say I threw dices or whatever, and I want to predict what the numbers were on the dices and so on, and I took a lot of measurements on how exactly the surface was laying out here, and the wind speed and everything and so on. The good part about AI and the bad part about AI is it's almost like a little bit of magic, that you give this old data to this AI algorithms, and it can actually find the behaviors and the math itself. You don't give it any I'm not telling it it's the wind speed divided by the angle of the table or whatever. I just provide the data, and I tell it like, okay, now the wind speed is this, and I throw the dices, and I let the AI decide what are going to be on the dices, the numbers. And if you have trained it in a good way and follow all the data science rules on how to do this, then you can do a quite good prediction of what the numbers will actually be. So it's the bad part of it. It's that it's a little bit of black box. There are a lot of research into explainable AI and so on. So if something goes really wrong, it's much harder than conventional to do debugging. To really understand, you need to go quite deep into it to understand what's going wrong and so on.
And I guess that's where the confusion comes from, is this black box element to it, right? Okay, it's hard enough for you to understand it as a computer scientist as opposed to, a commercial real estate professional.
Yeah.
I mean, if let's say you were then going to give some advice to one of those people, commercial real estate professional who's having to evaluate technologies, like what would you say to them about AI and like how they should be thinking about it and applying it, or where they would get like the most use from it, I suppose?
Yeah, I mean, in my mind, there's going to be like autonomous cars sooner or later. I think it takes some time, and right. We're still somewhere. I don't know how long it's going to take, but I think that in a lot of fields, it's going to be some companies who does this for real and so on, and they can basically get rid of all the manual labor of doing this, and they're going to revolutionize each field using AI. But it's going to take some time. It's not like some people think that we are very close to like artificial general intelligence. I would say that we're not so close yet. So everyone is doing like a narrow AI in their specific field, but they can really make it really, really, really good. But it's quite new area, and the other problem is also like some people think that the algorithms for the AI, that there are like, oh, you have to find an algorithm or so on. The problem today is that there are almost too many. Like every day or while we're sitting here, there comes out new algorithms all the time. And they have some benefits and they have some drawbacks and so on. So you have to test a lot of different algorithms and so on. And there are a lot of people sitting in the research in this field. But I think for the real estate sector, then it's absolutely going to be AI who controls most of the buildings. That's just a matter of time.
And that's, of course, the output of your system, right? Is this is control of the building management system?
Yeah.
By fly by wire, essentially.
Yeah.
Okay.
Yeah.
And that is, I mean, how granular does that get? I mean, are you controlling obviously the temperature, but to do that, you're controlling the different parts of it. I mean,
it gets down to the nitty-gritty details here, and we're controlling like all the heating circuits and like ventilation, how fast is the fan speed and pressures and all the down to the small things. Yes.
And what kind of results have you had with clients?
So I'm going to start with our dream case scenario,
of course,
because it's very, very much in this field. So what we really like is buildings who have like, they are connected, they have a BMS system, some building, but we mainly work with old buildings, like the current, that are already in place. If there are like really new ones who have a VAV control and so on, and a lot of good stuff, and they have put in a lot of time, we can't save as much. No. So we focus on the like, what we call it, like the gray, like the normal 80% of the buildings that are out there, the normal buildings, and we save like somewhere between 10 and 20% of the costs of the building, and we save even more. We save more on the electricity side, and a little bit less on the heating side. But there are also other ways to like. There's a lot of you can save a lot on the effect, on the power, and so on. And there are tariff structures, which means that you can. It's also very important when you use the energy, not only how much you're using. So that's a change that has more and more come into the field. So if you look on the cost perspective, that's where we are best.
Yeah. And I guess, this is a two-part question, because you're using AI to build this, train this model to specifically look at energy in buildings. Do you see other application? I mean, I don't know what your plans are in the future, but also just generally in commercial real estate, what else do you see AI being used to optimize buildings?
So the power grid and so what's happening here. I think that this is just my personal belief. I think that cars and a vehicle to grid will be a very good thing, since I mentioned that the power is very important and so on when you use this. And since all these cars have which are quite expensive, but they have a big battery inside of them, you could actually steer the building much better if you can kind of use the batteries which are in the car, and together with solar roof and so on, it even gets more complicated and so on. But I think that in the 10 years in the future or whatever, then a lot of cars are going to be electric and be in the buildings. I think that we're going to see models which are going to be you don't have to pay anything for parking here if we can use your battery for using that for the building and so on. So I think that we're going to see a lot of totally different ways, and I think this is really important for the heavy electricity.
And you're doing some work in that area anyway, aren't you?
Yeah, of course.
Do you want to talk a little bit about that?
Yeah. It's just research that we're doing. We're not steering any building where we control the charging for the cars yet. But we are of course looking into it and how you can do a little bit of smarter together with the buildings. But there are only some car brands who support. Actually, it's quite easy to select how much power the car should get. But if you want to get out of the car, then there's only Nissan Leaf and so on, and Tesla just released and so on. So it's we're really not there yet. All the manufacturers of the cars have to make up their mind of which protocols they're going to go with and so on.
But the other part to it, I guess, is the relationship between the building, not just the car, but the building and the electrical grid as well. I mean, you again, you're partnering, you're doing some work there.
Yeah. So we have our core business is running this machine learning and optimizing. It's the optimization theory together with the predictive power and so on. But we have another project which we are running, which is called ADR, automatic demand response. So there we have a lot of partners together with the energy producing side, together with the energy consumption side. So a lot of buildings, and now we're starting together with the CSAB, which is one of our biggest customers. We're running 78 buildings, 78 schools. They have a system called Solida that we're part of, and so on. So now we're going to control a lot more buildings where there are electrical heating and so on. So we can shut it off depending on the day and so on. So we get calls the producing side wants us to reduce the amount of usage and so on. So we can shut it off, but you can't only do it in a unsmart way. You have to do it in a little bit of smarter way. If you know the next day that you're going to shut it off, perhaps you can heat it a little bit more in the evening of the day before and so on. So you can basically move when the power is being used and so on.
That's interesting. And that's sorry, who was that client? Or partner?
CSAB.
Okay.
So they have basically all the public schools in Stockholm. So.
No, I think that's fascinating. I mean, what do you? I mean, again, this is just a pilot project, but do you expect this could be something potentially that you could feed into your current core product as well?
Yeah,
right?
exactly. So we basically want to achieve, like, this is our second project, the ADR project. It's not. We basically want to create a marketplace where we can have the demand and supply being done and so on. There are some marketplaces already there today, which are more on only the electrical side, but we are interested in doing this for the district heating and so on. So a little bit of different where we put our resources into and so on. But of course, we have. It's not only Myrsbo who will be on the response side, but we also have other companies who produces batteries and so on, and that are part of this. I think it's like 30 or 40 different people, companies and so on.
Involved in this. Yeah, okay. No, that's fascinating. Something else I wanted to ask as well, you talked about interfacing with the building management system, of course. Is it possible also to get other data? I know you talked about weather data, that kind of stuff from external stuff, but then also like there's systems that perhaps aren't connected to the building management system. Is that again useful to you? Do you collect that kind of stuff?
Yeah. So of course we get the weather data, and it's like 18 different parameters for the weather, like wind speed and if it's snowing and so on. So a lot of it's not only the temperature, it's a lot of different parameters for the weather. We get one thing that seems like trivial, but of course the time of the day and so on is really important, and it's going to find behaviors of like a building when people get in and get out and so on. And we have like usually to have a good indoor climate, you need to measure like the carbon dioxide and so on. And there are usually like temperature sensors in the building, but if there's something which is usually missing, it's the carbon dioxide sensors. So we can add them there. We're not doing it. We're more of a math company, so we're not installers or anything. But we have partners who does this. And the good thing is that we have this wireless and so on. And instead of going there traditionally with a electrician who has to go into the backnet lines or and so on and do all this hardware thing, we can basically have a guy coming there with a backpack, and he just put up these wireless sensors, and we have an API connection to them and read out all this data, and we actually send it back to their BMS. So from the customer perspective, it looks like all the sensors are connected to the BMS. Okay. But we actually at the point where we are sending all the normal, where we're controlling the set point, we actually send all the values for all the sensors as well. So
so they're like on a separate wireless network that then goes to you and then goes back into the BMS.
And it's much cheaper to do it in that.
No, I think it's brilliant. One of the other things that was interesting as well, or I wanted to ask about, like the data side of it as well. I mean, you mentioned that you're not getting as much data as you want, like to build these like massive models, but you're still getting a lot of data. I mean, how do you deal with it? How do you take that data, like take it out, store it? Where, I guess, is it? I mean, and it'd be interesting to hear that.
So we're using Azure, and we have like clusters. We're using something called Ray for Python. We have selected like .NET for all the coding language for all the integrations and so on, and Python as the AI language.
Python, okay. And then Azure is the Microsoft Cloud.
Microsoft Cloud. And there we have like clusters where all the calculations is being done and so on. Since this is quite compute intensive, we need to have like graphics cards for making all the calculations. It's not enough to run it on normal CPUs. But the good thing is that they provide this, and you can basically it auto scales and so on. Right, so just when we sit here, I don't know how many computers, but it's a lot of computers who just goes up and down and so on, depending on how much that are being needed right now. We're controlling every building every 15 minutes. But there's a lot of calculations, of course,
Right.
being done.
So you say the control every 15 minutes.
Yeah.
Like writing to the BMS to
Yeah.
tell it to do something every
Yeah.
15 minutes. Okay.
Yeah. So 24 hours a day, every 15 minutes, we do that thing. So.
And the data, you have some kind of database.
Yeah.
And that's in the cloud as well.
Yeah. Exactly. So we store all the data and so on, but we, of course, in the agreement with them, we are not allowed to give it out to anyone else and so on. But it's we need the data for being able to train and so on.
Well, I was going to ask that because actually, I suppose in some ways you really want to aggregate all of these different buildings to create your model, right?
Yeah. But it's very important for that each building is very separate. We can, of course, learn stuff from a lot of buildings and so on, like Tesla does with like their army of vehicles. They can learn from that one, but it's I would say that the cars are more alike, if you see what I mean, but buildings are much more different from each other. So we need to do special models for every building. And then we have like hyperparameter tuning jobs which goes around and like we have actually coded several different types of AI algorithms that we are using. We have like LSTM and attention-based models and so forth. And then we have like hyperparameter tuning jobs which selects which algorithm is best for this particular building. And it what we can see is that when we start a building in the beginning, when we have not collected so much data, it's usually selecting some algorithms which are better for less data, and then which is usually like more simpler linear algorithms, and then it switches to like time-based models once it has more data and so on. And all this it be done automatically. So, yeah.
Something else as well I mean, your background is maths, computer science.
Yeah.
I mean, when did you decide that buildings was going to be the problem that you were going to tackle?
Yeah. So I never worked with buildings earlier. So it was me and my partner in crime, a co-founder, Anders Kallebo, who started this company. And Anders comes from a background in buildings and have worked with energy efficiency solutions his whole career. I actually came from financial sector earlier, so I was using like machine learning for fraud detections instead. So quite different, but the algorithms are similar
principles. Yeah.
But it goes so fast what happens in the AI space. So those algorithms that were cutting edge back then are simple algorithms today. So I would say it's much more advanced than it was back then.
And, you know, with your perspective, like what was it like coming into the building technology space? I mean, I guess this is probably another podcast in itself, isn't it? But, I mean, are there things that you think, like, I can't believe that it's done this way, and like, why have you not changed this? And
yeah, a lot. I think we have been quite lucky that we were actually starting the company and so on in a period where the real estate sector have almost like realized that they were a little bit behind other sectors and so on. So there was some parts which I was like, these are stuff which were done in the 70s. Sorry?
Like what?
I mean, the Modbus protocol, or if we say something like that, or some of the BMS that I've looked into is, it's very strange. But that's just the reality. And they have been, some of the BMS systems, they have been running for 30 years and so on. And we are doing, we want to work with all kinds of buildings. So we have to make an integration to an old system. And it could be like a protocol which says like 3FFC, then that means this thing. And today every API is more structured and more easy to use and so on. But we just have to make it work. And I'm perhaps more used to sectors where like they're more cutting edge, and when something comes out which is new, everyone jumps on board on that one and so on. But here it's more like
okay, standardization. But is that apply not just to the equipment, but like basically the data, right? There's not really much standardization around data either, is there?
No, but we here in Sweden at least we have a quite good nomenclature or whatever it's called, and so on. But it's not the same everywhere, and there are some standards that's coming out. But of course, the problem with the standard is that there's going to be another standard and so on, and it has to be the big players who basically sits down and says this is the standard that we're going to go with, especially for the big BMS companies like the big four, Schneider, Siemens, Honeywell, Johnson Control, and so on. But today, it's not really one standard fits everything yet.
I mean, a great point, and you mentioned some of the bigger companies there. But do you also feel like there is, let's say, influence power in other areas as well? Like, and some of the, owners, operators of buildings, are they becoming more technology savvy and then sort of putting downward pressure on some of these vendors?
Yeah, I mean, there's even a field called Proptech today. I mean, there are lots of new innovation that's coming and so on. And I think if I see what the real estate companies are doing, they're really keen on searching for the new stuff today. So they are kind of like hunting for new stuff, and they want to make it a much more better sector and more modern and reap all the good stuff that are out there. So, but it's just that it has been traditionally a little bit behind, but it's going extremely fast right now, I would say.
It's something as well I've often written about, or see discussions about it, and this IT, OT, information, operational technology clash, right? Building automation being in the OT realm. I think one of the things that we see is like this skill level. And again, kind of we talked off camera about that, like you're trying to recruit people as well. I'm sure a lot of people are. Is that something that's holding back technology in buildings, not being able to get enough engineers?
Yeah. And like if I talk with a data scientist or a normal developer or whatever, then most people still don't know like the real estate sector is using like 40% of the energy in the world and so on. So they get like amazed and like, oh, why are there not more companies doing this and so on? And we were also talking about a little bit earlier about like the hype and so on. So if you go out and just search on Google or for like energy efficiency, AI, buildings and so on, you're going to find like thousands and thousands of hits. But really, there are like 5 companies in the world who does AI for buildings. So it's ridiculous.
For real, right?
Yeah. So it's very perhaps a little bit the marketing is a little bit ahead and so on. And there are lots of companies doing like dashboards that they can visualize the data and so on. But what's really separating and making it a good solution, I would argue, is like get away of the man in the middle, like having the actual system control the building instead. Not that you should look on all these dashboards and so on and realize and then go in and make manual changes. But we'll see what happens there.
Yeah. No, it's a great point, isn't it? It's great to be able to see the data, visualize it, but you've still got to do something with it. And ideally, well, the best way is to automate the whole process, isn't it?
Yeah.
So what are your plans as a company for the next couple of years?
So the next year is basically internationalization. We have already started it a little bit early, but that's our main plan. And of course, a lot of recruitment. We have basically doubled the size of the company in all ways every year. We want to keep on doing that and run a lot of buildings. And that's the way to make a big impact and save a lot of money for the real estate and also doing something good for the world.
Yeah.
So yeah.
And
Keep
like
on
an
doing what we're
ideal
doing.
client for you would be somebody, well, we also mentioned it before, right? So like older building stock or a mix of building stock. And I guess anyone with a lot of buildings, like the more buildings, the more money they can save.
Yeah, and it can always also be like a really complex building with a lot of things, and or using heating and cooling is always good, because then we can make them only go one, and so on. So we can optimize it more. The worse it is, the almost the better it is.
Better it is for you, right?
Then there's potential to save more energy, and the more modern they are, we can usually save less on those. So, but the majority of the buildings are like 80% of them are in
within
our target spots.
Yeah, right. Great. I mean, anything else that you wanted to mention, talk about?
Of course, if you're listening on this and you're a developer,
give me a call.
Yeah, definitely. Or engineer or interested in this field and so on. And also, like, if you just want to have a chat about this, then reach out. It's always fun.
And we'll put a link to your website in the description of the video for sure. Yeah, and of course, if you're an owner of real estate and want to save some energy, then come to us. But like, I think you make a good point, right? I mean, in terms of impact, I guess with engineers, that is also something that some will consider about. Like, there is an opportunity here to really impact on climate change. I know we've got some very lofty kind of climate change goals to reach, and I think buildings going to have to be a part of this solution, and they can't be part of the problem.
Yeah, exactly. And there are lots. I mean, I think that we have just like gone on the surface of what we can do. We could probably save a lot more and so on. And there's so many ideas and so little time and so on. So this is just the start of all the things that you can do with a computer and so on. And the second thing is like the tariff structures. Like, let's imagine that you have a server room, for example, in a building, and you can have an interval of what is the good indoor climate on the server room. Like, perhaps it's going, I don't know exactly, but 15 to 22 degrees or whatever you have. And the right way to steer the building in most times during the summer, it's probably that it's on the warmer side, close to the top.
Mm-hmm.
But you actually get paid for district cooling during winter. So the tariff structure is in a weird way of like, suddenly one day it just switches from costing a lot to. So the right structure, the right way to optimize the building is suddenly to use as much cooling as possible in this room, and so on. And the problem here is like the traditional way of like having people doing this manually. There's no one having time to change the whole building, how it's going to behave and so on, depending on like a new tariff structure or whatever. And there's basically no way in competing with a computer.
So an obvious problem.
So I see it as, in my mind, this is going to be like, it absolutely has to be computers who does this thing and more.
The most efficient way.
Yeah.
Absolutely. Great. Look, Jan, thank you for sparing the time today. Really appreciate it. Great conversation. And of course, wish you luck with the business. I'm sure it's going to go great.
Thank you. And thank you very much that I could come here.
Thanks again.